All right, so on page 30, we left off here with number 13. What are the 4 key principles of experimental design? What'd you say? Comparison is one of them. What is another key principle? Yes. Randomness or random assignment. Repeatability. There's one more piece. Control. Yes. We had control. We kept all other variables consistent. The amount of soda, everybody got approximately the same amount of soda. Temperature of the soda, temperature in the room. This was all the same for everybody. Activity level. We didn't have anybody in the corner doing jumping jacks. Everybody was pretty sedentary yesterday. We had random assignment. We had comparison because there were 2 treatments. There was Diet Coke with caffeine, Diet Coke without caffeine. And then we said another piece was repeatability or replication. Did we have that? Did we have replication? Yes, we had replication. How did we have replication? Yes. We had multiple people in each of these groups. So 21 participants was a decent size, right? We only had 21 people here yesterday. If I was concerned that gender played a role here, I'd read in a magazine article that women just naturally have higher resting heart rates than men do. If I thought gender might play a role in this, how could I adjust the experiment to take that into account? We could block. We could block by gender. Split you guys into groups by gender first, and then randomly assign the treatments. So let's talk about how we could have done that yesterday. Yesterday we had 21 people total. What would I do if I was going to outline a randomized block design based on gender? What'd you say? Separate them based on gender. So we're going to have males in one group and females in another group. All right, let's figure out how many we had yesterday of each. So males, we had 1, 2, 3, 4, 5, 6, 7, 8. Looks like we had 8 males that were here yesterday. There's 9 total in the class, but you were absent. So we had 8 males. Females, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, I just wanted to make sure with my count, like I can subtract it, but I'm like looking around the room trying to make sure that I'm counting the people that were here. 13 females. All right, so I've got people split by gender. What would we do next? Divide into 2 groups. How would we divide into 2 groups? Random assignment. So for the males, we want to do some random assignment. And for the females, we would also do random assignment. We could do it like we described above, only instead of 1 through 21, we would do the males 1 through 8 and the females 1 through 13. All right, so now we're going to split them up into 2 groups. What do we want to call our 2 groups? 1F, 2F, 1M, 2M. All right, so group 1M, group 2M, group 1F, group 2F. How many would be in each group for the males? 4 would be in each group. What problem do we have with the females? It's not even. Remember when we said we want these groups to be roughly equivalent? 6 in one, 5 in the other, or sorry, not 6 in one, 5 in the other, 6 in one, 7 in the other, so that we get it to add up to 13. I want these to be as equal as possible, but I can't have half a person in each of these groups. So do you want group 1F or 2F to be the one that gets 7? 2F, okay. They get 7. This group gets 6. What do group 1M and 1F do? They get the caffeine, sounds good. We get to decide whether that's caffeine or no caffeine. Be Diet Coke with caffeine. And so then the 2M and 2F, Diet Coke without caffeine. All right. So everybody drank their either caffeinated or uncaffeinated Diet Cokes. What now? Yes, compare change in heart rate for each group. All right. Now what? Combine the 2 groups and compare. Nicely done. So blocking by gender. First, you use gender to split them. That's obviously not random. Why do we do the blocking? We want to try to control for a potentially confounding variable. If I didn't think gender had anything to do with heart rate, then I wouldn't care about blocking by gender. I would want to choose something that I thought affects heart rate, something that influences heart rate. So we could have done, instead of by gender, maybe we could have done by whether or not they're an athlete and participating in sports. We could have done that for our blocking. Let's flip over to page 31. Could we use matched pairs to test the effectiveness of caffeine? Would that be possible? Yeah, I could have used matched pairs. Now, I would have needed either one more participant or one less participant because it would have to be even. There's a lot of things that we could use to match people up with. But again, we're using matched pairs to try to control for possible confounding variables here. So what kind of a criteria would make the most sense for me to use to match people up? We could look at initial heart rate. We could look at size as well, because size affects that. But since we had everybody take their heart rate at the beginning, we could use that. I could take everybody, put them in a list in order, least to greatest on their heart rates that you did initially. And then what would I do after I have that list if I want to do matched pairs? How do I decide who to match up? The first two from the list, and so they would have, what do you say? Similar heart rates. So I would either pick the two lowest or the two highest. I got to pick one end of my list to start on. I'm going to match them up. And so I've got them matched. What do I do with my match then? Flip a coin, randomly assign. I would want to be really particular, if this was a test question, I would want to be really particular that after I match these two up, I label one like person A and person B, and I flip a coin. If it lands on heads, what happens? Person A gets caffeine, person B does not. What about if it lands on tails? Person B gets caffeine, person A does not. We have to go through and explain that if it's a test question. I kind of took a little shortcut here. I didn't talk about person A, person B, but the big idea is that I would be pairing these heart rates together. Flip a coin to randomly assign one to caffeine and the other to no caffeine. This is the part that I would want to go into more detail on if this was a test question. And that very last sentence, I cannot begin to express how important this very last sentence is. Because if you don't say that, you have a bunch of matched pairs, but only 2 people participating in the experiment. Everybody should have their numbers written down. If you were here yesterday and you participated, you should have recorded your pulse at the end, and then everybody should have already performed this subtraction. Your new or final pulse rate, the one that we did at the end of class, minus the initial pulse rate. Everybody should have a number written down for that. In the interest of time, rather than having everybody come up to the board, I'm going to have my groups stand and I'll get numbers from everybody. So if you were in the caffeine group, go ahead and stand up for me. If you were in the caffeine group. All right, this was my group A. As I move around the room, I want to know what was the difference, your final minus initial. So I'm going to start over here, Abe. You said 16? 16, Matthias. 12. Once you've given your number, you can go ahead and sit down. 8. 16. Jameer? 14. Deborah. Okay, and that's fine. Javen. 12. -4. That's totally fine. I had negatives last period also. 20. 16. 2. All right. If you were in group B, if you were in the no caffeine group, go ahead and stand up for me. I'm going to start on the same side of the room. Boris, you got 8. 12. 8. 8. 0. 12. 4. You said 8? 12. All right. Fantastic. So that's my B group. All right. So what we're going to do, I'm going to need somebody to read these numbers back to me because I'm going to flip over to a website. I'm going to go to staplet.com, this website right here. We've been here a couple of times before. Has everybody got these numbers written down? All right, I'll wait just a second. So we had one person that had a mistake with their initial heart rate, so they weren't able to do the subtraction, and somebody else was not able to participate because carbonated beverages just do not work with their system. So you're right, that's not the 21 that we had. So we have 10 in one group and 9 in the other group. So I actually kind of like that came up because that's the kind of thing that does come up in real studies. Sometimes you have a group of 100 people and you can't end up working with all 100 people all the way to the end. And so we have those issues that come up where people... All right, so we're going to go to staplet.com. What kind of variable or variables were we working with? Quantitative or categorical? Quantitative. How many variables were there for quantitative? 1. There was only one variable because I recorded one number for every person that participated. Just one number. We recorded 2 initial values, but then we subtracted those so that we ended up with one variable that was the difference between your final and your initial heart rate. How many groups did we have? 2 groups. We had a caffeine group and a no caffeine group. So I'm going to choose the option here that says 1 quantitative variable, multiple groups, right here. What was our variable name? Careful. Change in heart rate. Think about what we recorded at the end. The change in heart rate was our variable. And then what were the 2 groups? This is caffeine and no caffeine, yes. All right, we're going to record the data for each of these groups. So if I could get a volunteer to read me the caffeine numbers. There were 10 numbers there. Oh, thank you, Faith.
16.
16.
12.
12.
8.
8.
16.
16.
14.
14.
12. -4. 20.
20.
Yeah, 16.
16.
And 2.
And 2. All right, and then no caffeine. Deborah. 8. 12. 8. 8. 0. 12. 4. 8. And 12. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. I just wanted to make sure that I actually caught them all. All right, I'm going to click on Begin Analysis right here. When I begin the analysis, it gives me a dot plot for each of these groups. What do you notice when you look at those dot plots? What stands out to you about the dot plots? Caffeine is more spread out than no caffeine. Where's the majority of the data for caffeine? Over here on the right. So this kind of has a skewed left appearance to it, right? We've got this tail off to the left. No caffeine is slightly less skewed to the left. It's more compact, smaller range. When I come down here to these summary statistics, we can see the mean for each of these groups. What was the mean for the caffeine group? 11.2. Record that on your page. There's a spot to record that. What was the mean for the no caffeine group? 8. Go ahead and record that on the page. So we had 11.2 and exactly 8, right? What is the difference between those? 3.2. So now my question is that statistically significant? Is a difference of 3.2 beats per minute a lot? No. Is it possible that that's statistically significant? Let's run a simulation to find out. Come back over here to the website. Do you see where it says perform inference right here? We're going to simulate a difference in two means. Do you guys remember when we did this with the cards? So this program is going to do the exact same thing, only virtually. It's going to take all of the data that we just fed it for both groups. It's going to mix it all together and then randomly assign it into two groups, find the mean of each group, and then subtract it and put down a dot. How many times should we have it do that? 50 times. All right. Nope, it did not take it because my numlock is not on apparently. Oh my goodness. Try it again. There we go. Finally. Okay, we're going to add those trials. Please go ahead and copy this dot plot into your notes. It goes from -6 to +8. Yes. What was our difference in simulated, or our difference in means? 3.2 was our difference. I'm curious how many in the simulations that they ran had a difference of 3.2 or more. Oh, I didn't want less than, I wanted greater than. There we go. What percent of those dots had a difference in mean heart rate of 3.2 or more? 24% of them. 12 dots. 12 out of the 50. 24%. I'm going to take this picture and paste it into the notes. So give me just a second. I promise it'll. All right, make that bigger on the screen. All right, is that big enough to see? So what percent of the dots are larger than the difference in means we got from our experiment? We got 24%, 12 out of 50. Is that statistically significant? What kind of a number are we looking for statistically significant? 5% or less. We made an assumption at the beginning of this. We assumed that caffeine did not have an impact on change in heart rate. So no, this is not statistically significant. Assuming that caffeine has no effect on change in resting heart rate, there is a 24% probability of getting a difference in heart rate of 3.2 or more purely by chance. So not a statistically significant result. Can we generalize our findings from this? Why or why not? I saw several people tell me no. Why can I not generalize the results from this? There was no random sample. I said you guys are going to be doing this experiment. We did not take a random sample of all students at Pike High School. We didn't even take a random sample of all AP Stats students. So we cannot generalize these results because there was no random sample. Can we determine cause and effect? Yes. Why? Because we were randomly assigned. So if I can't generalize the results, I can only talk about who in my conclusion? This class. So my conclusion would start with, for this class, Did we find convincing evidence or not? No. We did not find convincing evidence. I think I misspelled word. B-I-N. Yeah. I can't spell. All right, there we go. We did not find convincing evidence of what? Yeah. That caffeine caused a change in heart rate. At least not at the levels that we consumed it in. 3 ounces of caffeine is, or a drink with 3 ounces in it that contains caffeine was not enough to cause a change in heart rate. Now it's time to find out who read their book. Was this experiment conducted in an ethical manner? I did ask you guys. I didn't force anybody to participate that didn't want to participate. But this was not done ethically. In order for something to be considered an ethical experiment, it has to be reviewed by an impartial panel before it occurs. I have to write up a complete experimental design stating exactly what I'm going to do and how I'm going to do it, and then I need to submit that for review. And a panel of individuals decides whether or not this is acceptable. And if I get the thumbs up from that institutional review, then I can proceed with the experiment and it would be considered ethical at that point. Now, do you think I horribly violated anybody's rights?
Yes.
It was Diet Coke, yes. But you all knew going into it that it was Diet Coke. I was honest and upfront at the beginning. So while it wasn't an ethically conducted experiment, I did try to make sure that we had informed consent at the beginning. What we're going to spend our last 10 minutes doing is working on a free response question. I'm going to pass a free response question around. You guys are allowed to use your notes. You are allowed to work in groups. I can only give about 5 minutes to work on this so that we have time to review the answers. All right? So these are coming around. Start with where the number is. There are 3 parts to this question. 2 parts are on the front side. There's 1 part on the back side. 5 minutes so that we have time to go over answers. Timer starts now. All right, so that we have enough time to actually talk about this. I know not everybody's done. There's probably a bunch of people that haven't even gotten all the way to part C yet. What are the experimental units? I'm hearing a lot of good things. Be very careful here. What is it that's being experimented on? The driveways. 60 driveways would be our experimental units. If you said 60 new homes, that would not work. You have to talk about the driveways. You could say 60 new homes with driveways, yes. What would the treatments be? Concrete with fibers, concrete without fibers. Response variable. Think about exactly what would be recorded. What would be recorded? The rating of the severity of the cracks after 1 year. You can say on a scale of 1 to 10, but you do not have to. All right, so down at the bottom of the screen. Rating of the severity of the cracks after 1 year on a scale of 0 to 10. When you're writing these down for experimental units, what is it that's being experimented on? For the treatments, what are they being randomly assigned to? And for the response variable, make sure that you know exactly what is going to be recorded about each of these things. All right, talk to me about an appropriate method that we could use to randomly assign. Label the driveways 1 to 60. Use a random number generator to do what? Select 30 unique numbers. Yep, assign that. Assign those 30 driveways to receive, I said concrete with fiber, and the remaining 30 get the concrete without fiber. You got to talk about what happens to all of the driveways, so make sure you mention which ones don't get the fibers. All right, then over on the back side, even if you didn't get there, let's go ahead and flip it over and look at it. It says, suppose the developer finds that there is a statistically significant reduction in the mean severity of cracks in driveways using the concrete that contains fibers compared to the driveways using concrete that does not contain fibers. In terms of the developer's conclusion, what is the benefit of randomly assigning the driveways to either the concrete that contains fibers or the concrete that does not contain fibers? So basically, why did he do random assignment? To determine cause. There were two things that they were looking for on this particular question. We want to see cause and effect, but we always have to put everything in what? Always put it in context. So specifically, what causes what? Yes, whether or not it contains fibers affects or causes the rating of the severity of the cracks. So there were two things that they were looking for a fully correct answer here. You had to have both of those pieces. Tomorrow, we will start and warm up with another free response question. We'll talk about that, and then I'll take any questions you guys have off the test review. I've got another free response question on deck after that in case we decide that we want more practice with those style of questions. Have a good one, everybody. I'll see you tomorrow.